When you take a flight, as the plane takes off, the beautiful flight attendant will remind you. Put away the tray table, straighten the seat back, remove your headphones, and open the window shade. After a long cruise, the plane is about to land. You haven't finished your movie yet, and the beautiful flight attendant appears again, asking you to remove your headphones, put away the tray table, straighten the seat back, and open the window shade. The air on the plane is very dry, and you've drunk a lot of water. You want to use the restroom, but then they tell you it's closed, so you have to hold it for a while. Then you wonder, why are they so strict during takeoff and landing? It's actually simple because takeoff and landing are the most dangerous. The 3 minutes of takeoff and 8 minutes of landing are known as the black 11 minutes. Even though these 11 minutes are short compared to the total flight time, the proportion of air accidents in these two phases far exceeds half, which might not align with your intuition. Speaking of the landing phase, the plane isn't that high. I can even see tall buildings and cars on the ground. It feels very reassuring. During the cruise phase, we're above the clouds, several thousand to tens of thousands of meters high. If we fall, wouldn't we crash into pieces? Oh, come on, falling from 10,000 meters versus 200 meters. How much difference do you think the outcome will be? Actually, the reason takeoff and landing are dangerous is because of the low altitude. During these two phases, the pilot is very busy adjusting the engine throttle, extending and retracting flaps, extending and retracting landing gear, and being cautious about bird strikes. When busy, it's easy to make mistakes. The crucial point is that after a mistake, there's little time to correct it. A drop of 200 meters, and it crashes to the ground. But the cruise phase is different. It requires hardly any operation. Pilots are so relaxed, they could even play a few games. Even if something urgent happens, like clear air turbulence causing the plane to suddenly drop 2,000 meters, pretty exciting, right? Then you look at the altimeter, and it was a false alarm, with 8,000 meters still remaining. From the plane's perspective, frequent configuration changes can increase failure rates, like extending flaps. They might get jammed, and the landing gear might not come down. If the wheels can't be deployed, the plane can only make a belly landing. Even if the landing gear comes down, at the moment of landing, there's a sizzle and white smoke, leaving black brake marks. That's not touching the runway. That's clearly an impact. So the three legs of the plane, the landing gear, are under a lot of pressure. Besides the dozens or hundreds of tons of the plane's own weight, there are enormous axial impact loads, horizontal loads for deceleration, and lateral loads from crosswinds and skidding. Guys, when you feel stressed one day, think about the landing gear of an airplane. Even in this situation, James isn't entirely sure, as every piece of airplane landing gear is extraordinary. The main materials used are insanely strong, ultra-high strength steel and titanium alloy with extraordinary strength-to-weight ratios, and they're all forged because, as you know, forged parts are way stronger than machined ones. Do you know how heavy the main landing gear of a Boeing 777 is? The forged parts alone weigh 3.2 tons. Before production, in the development phase, an important step is to first understand the loads it will bear. Only then can we determine how sturdy to make the landing gear, right? There are many factors to consider, as Newton already told you. The momentum theorem is written like this: F equals m times delta v divided by t. So you have to consider the maximum landing weight m of the plane, right? You have to consider the descent speed of the plane, right? You also have to consider the landing time t, right? What affects landing time then? The hardness of the tires. Additionally, you have to consider the plane's heading speed, pitch angle, yaw angle, and the friction coefficient between the tires and the ground. There are so many, at least a dozen. And what you need to do is use these dozen or so parameters to calculate the load on the landing gear. The mainstream methods now are multi-body dynamics and finite element simulation. Hey, key element awareness, did you think I was going to recommend simulation software to you? Oh, simulations are too slow, whether it's multi-body dynamics or finite element. The modeling process is quite exhausting. You always have to define connections, various forces, and contacts, all of which are labor-intensive tasks. In comparison, data methods based on machine learning, it's much faster. You can first use simulation to calculate a batch of data. Then, use this data for machine learning, summarizing the patterns among the data, resulting in a data model. After that, you can use the data model to replace simulation. Quickly calculate loads. The principles of machine learning are not complicated, but implementing it was not simple before because you needed to write code and understand machine learning algorithms. And these are often the weak points for aerospace and most mechanical engineers. I'm already exhausted from studying airplanes, and now you want me to study algorithms and code? That's asking too much. To address this pain point, Tianfu's intelligent data modeling software DT Mauer offers machine learning with a very low barrier to entry. It's a godsend for those allergic to coding. All you need to do is drag and drop nodes, then connect them. It's like building blocks to achieve zero-code data modeling. If you're not into airplanes, that's okay. As long as you have data, it can be used for automobiles, electronics, and more. Many people are now wondering, what exactly does industrial artificial intelligence look like? I believe there's no single answer to this question. As a leading industrial software company in the country, Tianfu Software has been continuously trying and exploring, providing its own answers through practical cases.